Hey everybody, so we are going to be talking about triangle centers on the coordinate plane. So let's first discuss and remind ourselves what triangle centers are. So remember, an orthocenter is the point of concurrency created by altitudes. This is the orange apples. And remember that altitudes, they're just lines that are perpendicular to the opposite side. And instead of writing out perpendicular, you can also just use the symbol of perpendicular. Oh my goodness, let's go. Like that. And notice how I'm shortening the word opposite. So as you're going forward, you need to start thinking about ways that you can use your symbols to shorten your notes, but still leave them in a manner that's understandable a year from now. All right. Now, a centroid, okay, that is a point of concurrency created by medians. This is crazy monkeys. Okay. And medians, remember, they're going from the vertex to the midpoint of the other side, creating two congruent parts. Now, it doesn't matter at what angle. So we could even think back to chapter 1 and call them segment bisectors of the opposite side. And I am going to run out of room. Oops. Okay, I hope that you understand that means opposite side. Since this is not going to matter. At that point, it's not going to let us work. All right, the next one is in center. And remember, this is I am beautiful. So this is with angle bisectors. So what that means is that it's going to split this angle into two congruent parts. Now, guess what? That's all it is. Okay, which are lines that bisect angles. Then you've got your circumcenter. Your circumcenter is from colorful, pretty birds. And these are made by perpendicular bisectors. So this one is kind of different than the other ones that we've talked about so far. Is it uses the midpoint as its starting point, and we'll talk about this more later. And it has to be perpendicular with that midpoint, and it just goes and intersects it. It doesn't matter if it's at the vertex or not. And let me adjust my drawing because it's just a little bit off. Okay. And if you wanted a drawing of the orthocenter, we're going to pretend that that's a right angle. I know it's not right now. Okay. All right, now a perpendicular bisector, so it's going to split the opposite side in half. So it's going to be a segment bisector, but it's going to be a perpendicular segment bisector. And I'm going to just abbreviate perpendicular in this one. There we go. Now, so the three skills that we have talked about, remember, on the coordinate plane that we're going to be using is we are going to be talking about slope, distance, and midpoint. Now, here's the deal. We will not end up using all of these skills. In fact, distance right here will not be used to find any of these three special segments. In fact, there is nothing to help us find in center right here. And it's not even distance that helps us find it. So that is one that we will not be able to find on the coordinate plane. An orthocenter, because we're working with altitudes, you can find that one with slope. A centroid is made of medians, which means you can use that using the midpoint formula. And a circumcenter, since it is both, uses midpoint first, and then it uses slope to find the perpendicular bisector. Remember, not only is it splitting it in half, but it's doing it at a 90-degree angle. So, let's try it. We're going to do with orthocenter first. Orthocenters, remember, they are with altitudes. And so the first thing you have to do in order to find something that is perpendicular on the coordinate plane, you need to find the slope of that line, or in this case, each side of the triangle. You're going to graph each altitude by starting at each vertex and using its corresponding perpendicular slope. And you're going to do it from the opposite side. And then in order to find the orthocenter, remember it's the point of concurrency of three altitudes. That means it is the intersection of the three altitudes. Okay, so I'm going to do this first example here with you of triangle RST. The first thing that we are asked to do is to find the slope. Remember, slope is lowercase m. And since I'm going to find it for RS, I'm writing capital RS as a subscript. So a superscript is like an exponent, a subscript is below, and it thinks submarine. And all I'm going to do is rise over run. So I rose 8 and I ran 6. So it's 8 over 6. Now you can go ahead and simplify that, which gets you 4/3. Now my second step is that I need to graph the altitude by using its perpendicular slope. So your slope that is perpendicular to RS. First off, notice my notation. Okay, this is RS, this is perpendicular to RS. For perpendicular slopes, remember, you're going to put the thing down, you're going to flip it, and then you're going to reverse the sign. So if it was a positive, it becomes a negative. And you're going to graph it from the opposite side or the opposite vertex. T is opening up to RS, which means we are going to go down 3 to the right 4. But you know, I'll come back to that. I like doing orthocenter all at once. So we're going to find the slope of ST. We're also going to find the slope of RT. So I want you to go ahead and pause your video and find the slopes of the ones in yellow and blue. So of ST and RT. And then find also the perpendicular slopes for it. All right, now that you are back, you've unpaused your video, you'll notice that the slope of ST was down 2 over 1. And you can leave it like that, or you can write -2 over 1. And the slope perpendicular to it would be 1/2, and it would be a positive 1/2. Remember, you put the thing down, you flip it, and you reverse that sign, and that's how we got that perpendicular slope of 1/2. Then you've got your slope of RT. Notice this is a horizontal line, like the horizon. You can make a 0, or if it helps, you can make a Z from that horizontal line, and your slope is 0. The slope to the perpendicular slope to any 0 slope line is going to be something that is undefined in order for it to be perpendicular again. Because think about it, right? We literally make that to show a right angle. Okay, and undefined, see, you can also consider that as no slope if that helps you. Okay, and let's start from the back. So we're going to start off, and I'm going to graph the line perpendicular to, RT. And I'm going to start from this opposite side here. So I'm going to go all the way up and down. And that is perpendicular. If it helps you to draw your right angles, you can. And I'm going in backwards order. I'm now going to do ST. And this is the vertex opposite it. I'm going to go up 1 to the right 2. And I'm going to continue doing that so that way I have an easier time making my line as straight as possible. Now I can cheat since I have my iPad, so it's doing it autocorrect. Now this next one, we've got -3/4. And when I start at T and go down, I can't go down 3. I don't have enough room. So what I would recommend that you do is I would turn your paper around. I can't really show you that on my iPad, sorry. But you're going to turn it around, and you're still going to get the same points. Okay? And you kind of already have an idea by your second line that your orthocenter was going to be -2, 1. Now for your homework and any other time, I would still want you to show your work for all 3 of these things and do all 3 lines. That's a way for you to double check your work. All right, let's do centroid. And I'm going to go a little bit faster now that you've kind of got the handle on things. Centroid, you are going to remember working with median, so that means you're going to use the midpoint formula. You're going to find the midpoint of each side of the triangle. Then you're going to connect the midpoint of each side to the vertex or angle created opposite the side. These 3 lines are your medians. And then you're going to find the intersection of the 3 medians to make your centroid. Okay, so whenever I'm working with midpoints or anything like that, I like to have all of my points labeled. Okay, so let's go ahead and go on this coordinate plane, and let's go ahead and label points J, K, and L. All right, so you should have gotten those points as long as I know how to count, which let's hope we do. And I want to also point out that notice I used a capital M for midpoint and then a lowercase m for slope. Notation is super important. Geometry is when you first get exposed to this, and you're going to keep using that for the rest of your math career. So if something is lowercase in the formula, keep it lowercase. My calculus students will tell you the same. All right, now remember your midpoint is just an average of your x and y values. So you're going to do -2 plus 10, and you're going to divide that by 2 to get the x value of your midpoint. And that's going to get you 4 because -2 plus 10 is 8. Divide that by 2 and you get 4. Same thing, you can do 5 plus 9 and divide that by 2 and you should get 7. And with centroid and medians, just because there are so many points and I have to keep track of the vertex, what I like to do is graph my midpoint right away, and I do 4, 7 here. And then it doesn't matter what angle it is, what angle it's intersecting, I'm sorry, and it just goes to the line it needs to. Okay, so to the point it needs to, I'm sorry. It's going to go to the angle or the vertex opposite this side. So notice angle L is opening up to JK. Okay, so next thing, I want you to go ahead and find the midpoint of KL and the midpoint of JL. Now, by the time you get your midpoint for KL, you probably have a decent idea of where your centroid is going to be. Okay, but just in case, keep going and find your midpoint of JL as well. Now, this is pretty easy to do in your head, and I will take it as long as you show that you found the midpoint. So writing this down and having your notation, I'll take it on your work like that. So this is 10 plus 4, 14 divided by 2, you get 7. 9 minus 5 is 4 divided by 2, you get 2. So I'm going to get 7, 2. And it's going to go to that vertex right here, opposite it, and intersect. And let me try that again so it's a little bit more perfect. I know I'm cheating anyways, but you can use your ID to make more perfect lines if you'd like. All right, and then we've got JL, and you should get 1, 0 as the midpoint here. And that's going to intersect here. And granted, my lines aren't completely perfect, but you do notice that your centroid is going to be 4, 3. Awesome. So now you've done centroid and orthocenter. So now let's go to circumcenter. Okay. Now the circumcenter, remember, it uses both midpoint and slope, and the order is going to matter because it doesn't start at a vertex. It, in fact, starts at the midpoint. And then you use the perpendicular slope. To graph the perpendicular bisector. And then to find your circumcenter, that is the intersection of your 3 perpendicular bisectors. All right, so this one, your circumcenter, is a little bit more work and it's a little bit more tedious, but it's the same stuff that we just did. And before we get started, I'm sorry, I forgot my alphabet apparently. And this right here, that should be point C and not B. So it should go A, B, C. Okay, I want you guys, and I'm color coding to help you. Sorry about that, y'all. Using some primary colors, and it's all good. I want you guys to find the midpoint of AB, the slope of AB, and then the perpendicular slope of AB. And if it helps you, you're more than welcome to go through and label A, B, and your actual C. Right, so for your midpoint for this, you should have gotten -4, 2, so right here. And then your slope of this, you went up, let's see, 1/1, right? If you want to write 1/1, you can. If you just want to write 1, that's fine. And when you're getting the perpendicular slope, you're going to get -1. When I am working with Circumcenter, then I like to graph my perpendicular bisectors as I go. So I'm going to go down 1 to the right 1, down 1 to the right 1, and I keep going to help my line be as straight as possible. It's okay if it goes beyond the triangle. Okay. And notice it's not intersecting with any vertex here. And that's really special about your perpendicular bisector. Okay, it doesn't need that vertex. Remember, we use that midpoint. So now what I want you to do is I want you to do the same thing, but find it for BC Exactly what we did. And I want you to check it as you go, because if you mess up in one spot, we're not happy about it. All right, so for BC, you should have gotten the midpoint of 2, 2 right here. Your slope of your original line was -2 over 1. So when you put the thing down, flip it and reverse it, you get 1/2. And even though it's not intersecting with the triangle on the inside, as long as I have 2 points, I can make my slope. And if you want, you can also turn your paper around to help you find these other points that I am graphing. And you see that your circumcenter is going to be -2, 0. But we want to check, so we're going to find the midpoint of AC, the slope of AC, and the slope perpendicular to AC. Now, the midpoint of AC is going to be super easy because it's a horizontal line. And I know that means that my Y value is going to stay the same. I count up how many boxes these are, and that's 12. So half of 12 is 6, and I do 6, so I do 1, 2, 3, 4, 5, 6. So I got -2, -2 as my midpoint. If that didn't make sense to you, do the formula and you'll get the same thing. All right, the slope of AC, because it's a horizontal line, it's going to be 0, which means the slope of a line that is perpendicular to it is going to be something that is undefined. And that means it's going to be a line that goes up and down. Don't you dare stay straight, because it is not straight. Now, you will also notice that I am putting right angles over here. And that's just to help me remember where it is perpendicular to. Okay? And guess what? Now you've graphed all of these on the coordinate plane. Thanks for watching.